I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to discuss the topic on Coulomb's law for the course Electromagnetic Fields and Waves. So now we discuss the recall of previous topic is curl. Curl means the rotation or circulation of a vector field. It indicates the tendency of a field to rotate about a point. Curl is a vector quantity obtained from a vector field. The mathematical expression of curl is del cross A. Now, the topics for today's discussion is Coulomb's law, introduction, statement of the law, its mathematical expression, the vector form of the law, superposition principle, limitations, and also the applications. So, we are going to discuss the Coulomb's law in static electric field in design thinking way. The first part of the design thinking is empathy. So, now we are going to see what is Coulomb's law. So, matter contains positive and negative charges. The electric charges exert force on each other when it is in static electric field. So this Coulomb's law explains how the interaction happens between the stationary charges or the charges which are at rest or in the static electric field. Now, the statement of Coulomb's law is given by the force between the 2 point charges in static electric field is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them, and it acts along the line joining the charges. So now the mathematical expression of this Coulomb's law is the defined part of design thinking. So Coulomb's law, the force exerted on the point charge by another charge is given by F is equal to K into Q1 Q2 by R square. So in this expression, Q1 Q2 are the charges, and in coulombs, R is the distance between the 2 point charges given by the unit meters. K here is the proportionality constant given by 1 by 4 pi epsilon naught. So in the defined part, the vector form of Coulomb's law is given by F vector is equal to 1 by 4 pi epsilon naught Q1 Q2 by R squared multiplied by the unit vector R cap. So here the force is given by F vector, Q1 Q2 charges, R is the distance between the two vectors in two charges in meters. Here the term epsilon naught is permittivity of free space, and its value is 8.854 into 10 power minus 12 farads per meter. So this is the permittivity value of air or free space. So here the force is repulsive for like charges and the force is attractive for unlike charges. So the superposition principle, a very important principle in a static electric field, it gives the total force and it is the vector sum of individual forces in an electric field. We can apply the superposition principle to multiple charges and the basis for electromagnetic field calculations. So if an electromagnetic field contains many number of charges, so there are different forces are applied. So in order to sum the entire forces, we have to use the superposition principle. So this is very much important in electromagnetic field theory. So now the limitations of Coulomb's law. Superposition principle, it simplifies complex systems and applicable to linear systems. But the limitations of this superposition theorem is it is limited to only the point charges and not to surface charge, linear charge and volume charge. And it requires only the stationary charges, not applicable to moving charges, and not for relative speeds, and needs homogeneous medium, and it assumes the isotropic medium also. We know that the homogeneous isotropic medium the permittivity electric field E, and the dielectric constant D, uh, that is dielectric flux density D, are constant throughout the medium. So now there are various applications of Coulomb's law. Some of the applications can be given by it is used for the calculation of electric force. So when there is an static electric field, to find out the force exerted by one charge on the other charge can be calculated by using uh, Coulomb's law. So and the electric field is force per charge, so we can also calculate the electric field by using this Coulomb's law. And design of capacitors. So Coulomb's law is essential when designing the capacitors. And these are some of the applications of Coulomb's law. So far we have discussed the previous recall of previous topical and Coulomb's law, the fundamental concept of Coulomb's law, the statement. We have seen that how the force is on the 2 point charges, and the mathematical expressions we have seen. Vector form of Coulomb's law is also discussed. Superposition principle, we have seen the limitations of superposition principle, its advantages, and also we have seen how much important the superposition principle in the static electric field, and also the various applications of Coulomb's law. So the Coulomb's law gives the very important role in electromagnetic field for finding the force. So if we find the force, we can easily obtain the electric field, and if we obtain the electric field, we can calculate electric flux density, potential, everything. So thank you so much. Thank you.